हाँ विपुल, मेरी आवाज आ रही है?
Yes, sir.
अच्छा। Only four students available. It means they do not know the class. Okay, fine. Let me start with course. 21 MET 804, that is design of mechanism. So I uploaded this syllabus in Google Class. This course having 6 units and lecture plan are also written besides. Basically, this is the advanced course which you studied in your undergraduate, that is kinematics and dynamics of machines or theory of machines. Fine. So course code is 21 MET 801 and it is a 3 credit course, means 3 lecture per week. Of course, tutorials are not there and practicals are not there in this course, but class work and assignments will be provided time to time after class, and you have to submit the classwork. Right? So, out of suppose 100 marks, the class assignments carries 20 marks. So, you have to do assignment properly for this course. 40% marks for midterm. No, 30. 30 for midterm. 20 for classwork or assignment, and 50 for end-term examination. So that way, the assignment, midterm, and end-term varies 30, 20, and 50. So overall, it is 100. So there are two exams, midterm one, or not all midterm, only midterm book, and end-term, and some class assignments. See, out of see here course content that is are designed very beautifully about the kinematics and dynamics. How to kinematics and dynamics fundamental bring into the design, right? Machine design. So when we design, how we want to design a particular device or machine, then what will be the way? What you want to do that machine design course that consider all the strength design, machine component design. But this is considering overall overview of the machine, how it works, what is its degree of freedom, how do we perform synthesis, analysis, dynamics, and some units are added for particular design of cab design. So in fundamentals, again, 2 3 class, I do not devote to the fundamental of mechanisms. In that mechanism fundamentals, we try to define pairs, their classification of the pairs, degree of freedom, kinematic chain, binary, ternary, and quaternary joints and links, degree of freedom for planar mechanism, and again we review the Grubler criteria. Right? Uh, After that, inversion of mechanism, particularly for four-bar slider crank mechanism, and their inversion, and double slider crank mechanism and its inversion, then number synthesis paradoxes, why not some mechanism follow certain rules like a Grubler criteria for finding degree of freedom. And we also take up some industrial problems and convert into kinematic sketch and degree of freedom. Right? In second unit, that is our 8 lectures, where synthesis is defined, particularly three types of synthesis: function, path, motion, and then there we will also do some programming for synthesis. In the graphical synthesis, we also touch the coupler curve, cognates, straight line mechanism, and dual mechanism. This type of application. In Unit 4, kinematic analysis, once we have some conceptual design of a mechanism, and then we want to know the behavior of kinematics. Kinematics means positions, velocity, acceleration of link, or a point of link. Also, we consider some design issues like transmission angle, toggle positions, circuits, branches, and then analytical formulations for velocity and analysis, acceleration. Unit 4th, that is very important unit, in which instead of doing graphical synthesis, we will perform some analytical methodology to find the solution. Right? In old days, people use graphical methods because computers or some softwares are not available. But nowadays, we can use analytical formulations, try to develop equations, then try to solve them for our mechanism. So there we define some synthesis methods and methodologies and comparison of graphical and analytical methods. Some important terminology there: center point circles, synthesis of multi-loop mechanism, and optimization methodology. तो डीयू की तैयारी कर रहे हैं। नहीं, वो इंजीनियरिंग में नहीं जाना चाहता। Sixth unit, that is dynamic calculation of forces in joints, driving force, shaking moment, shaking force, shaking torque, and then balancing. Here we are going to define the purpose of balancing and what does mean balance, and some optimization techniques to reduce vibrations. Also, we consider one beautiful mechanism, that is CAM design. Here we define the terminology for CAM. There was position, velocity, acceleration, jet diagrams, and their profile, CAM profile curves, right? And sizing. So I suggest that you use MATLAB for solving the problems. If you are not aware about MATLAB software, then we have a software in our computer center. Sometimes you can use a crack software and understand initial how it works. We use a very in detail for this course. Right? So this is the overview of the courses. Total 40 lectures. I recommend following books. These books, Kinematics and Dynamics of Machinery by R.L. Norton. Very cheap books available in India. You must have this book. Second book is a very comprehensive book regarding synthesis and analysis, that is the mechanism design. New version is also available. It is available in two volumes, volume 1 and volume 2. Volume 1 is fundamentals of kinematics and dynamics, and volume 2 is particularly synthesis. It covers both planar and special mechanism, including robotics mechanisms. Okay. Two other reference books I suggest, that is Kinematic Synthesis of Linkage, that is very old book, but very good book for fundamentals. That is written by Hartenberg and Devanik. One more book is available with MATLAB programming, and that is Mechanism Design, Visual and Programmable Approach by Kevin Russell, Shank, and R.S. Soji. If I also encourage you that from time to time you go online resources available. So two of them I see it. These are the good NPTEL lectures, Theory of Machines by Professor Sujata Srinivasan, IIT Madras, and NPTEL Kinematics of Mechanism and Machine by A. Das Gupta, IIT Madras. So these two courses are also available for fundamental on NPTEL. Right? So you must check that to time. This is overview of the course. Now today I start fundamentals. So I share my notes. So fine, today we discuss some fundamentals. Before the screen is visible.
यस सर।
Okay, fine.
सर आप अपना वीडियो कर लो, उससे आवाज साफ आ जाएगी और भी क्लियर।
हाँ बताइए क्या कह रहे हो?
सर आप अपना वीडियो ऑफ कर लोगे ना तो और क्लियर आवाज आ जाएगी।
वीडियो ऑफ कर देता हूँ, ठीक है फाइन। Yes. So machines is made of mechanisms or collection of several links, joints, springs, and dampers. Right. So there are two distinct aspects of the machines. One minute, I am finding PPTs. Anyway, so machines means having moving elements, right? Moving links, moving joints, all these things. So to analyze the proper motion of the links, these are my notes. So let's come to our fundamental, what is motion of a rigid body. You know the motion of the point. Motion of the point means it has only translation. Point has a new size, so it is not having any sense for rotation. So any link of a machine or a mechanism is considered as a rigid body if there is no flexibility in it. Then it has three type of motions. One is pure rotation, pure rotation, pure translation, and then combination of these is the complex. Right? So link may be either in pure rotation or pure translations, or both motions exist. Then it is a complex motion. Hmm. So, question is how do we measure the rotation or angular displacement, angular velocity, angular acceleration? And second one is translation means linear velocity, linear displacement, and linear acceleration. Right? And if both are exist, how do we analyze simultaneously for rotation as well as for translation? So the rotation means displacement. This is one body, suppose, and after some time, it reach here, right? Same body, and this is my suppose reference frame, inertial reference frame, fixed frame, right? And origin 0, 0. So how do I measure the rotation of this body? It's t equal to 0. It is here, and after some time t, its position is this one. So my question is, how do I find position of body? Position of body with what? Hmm. Suppose there is a point. This is a point, and this point is t equal to 0 here, and after that this point is reached here. So the position of point I can measure by its position vector, means in Cartesian coordinates x, y, z coordinate. So this is the position of a point x, y, z. And here from this position to this one, this is the displacement. So what is the change in x coordinate, what is change in y coordinate, what is change in z coordinate, that way we can find the displacement. So this is known as linear displacement and this vector. In case of body, what is the position of the body? So body is nothing but a collection of infinite points. Right? Means I must know position of all points, and it is very difficult. Position of all points, it is equal to 0. Position of all points after a time t. So what is? How can I find the position? This position after time t, when body is moving in space. Hmm? Any idea? Anyone? Who would say?
Sir, we consider a axis about which body is symmetric, and we analyze that axis the how it is changing, translating, or rotating.
No, no, you got the question. See that slide. There are infinite points. Correct? Number one. This body is made of infinite points. And my objective is to find the position of body. Position of body means I know position of all points. So here position of all points is t equal to 0 is this. After time t, position of this point is this. Then what is the position of all these points? That way I can know position of whole body. So is it not useful that we find the position of each point? Is it correct? If we are not able to find position of each point, then how we can proceed to find the position of any point on the body? Repeat, Mohit.
Sir, we find the center of gravity of the body, and
I do not know center of gravity. This is again a hypothetical concept. I do not know the position of ball, center of mass or center of gravity, whatever you call. These are again some analyzing concept. As such, there is no point. I cannot say that this is the center of gravity. No, this is for analysis purpose. So in position analysis for a rigid link, suppose I know the position of a point on this body. Right? Number one. Because position of this body is known. So position of this point is known. Any point. And then I draw a line on it. So there are two things. See here, two things. So I am discussing two things. One is rotation, second one is translation. Here rotation and translation both simultaneously happening. So I measure translation by locating point, and I measure the angular displacement by drawing any line over it. Right? Because to know the angular displacement, I must have a line. Otherwise, how can I measure the angular displacement? Right? So this line may be any arbitrary line. You can draw a line passing to point A, and this is my AB line. Right? So initially, I take one point A and a line passing to point B over the body or in the body. Right? Now, after time t, this point is location A, 1, and this line B, 1. This is line. So what you notice? You notice that point A moved from A to A1. This is known as translation. Right? And the body is rotating, and means the rotation is captured by line AB. So line AB now in new position A1, B1. So if I draw initial reference line parallel to initial line AB, this one parallel to this one, then this is my rotation. Right? This is now theta. And this is my displacement, means x displacement, y displacement, and z displacement. Means if I consider planar body, let's forget about the z. So how many parameters I required to know the position of body? 3, x, y, and theta. I want to know the position of any point C. So this this body is defined completely. So this position of C is how I calculate. This is angle alpha because I know AB, I know AC because this whole body is defined already. It is known. So angle alpha is known. This body is known. It is rigid. So distance between points remain constant. So knowing the coordinate of A and knowing the length of AC, which is known by virtue of body. So by knowing AC length and coordinate of A point, I can find position of point C. From my initial position AB, AB से ये कितना है, right? Now this point coming here C, this is now C1. So C1 now this already is alpha. This is alpha from A1 B1 to AC1 because the distance between A1 C1 B1 C1 that will not change. Only change is angular theta. So the position of C1 is determined by angle theta plus alpha. Right? So you can find the position of all point by knowing angle theta and displacement x and y. So that way pure rotation is defined how? A reference line xy, any line AB is drawn and it is now rotating. So the angular displacement, it changed the line AB orientation and this orientation change is captured known as theta. So that is known as pure rotation and displacement of A is pure translation. So a reference line drawn on body through a center or any chosen point changes only its angular orientation line on the body. All points on the body describe arc about the center which has no motion with respect to face. So I am here discussing pure rotation. Means this body is rotating this way. You assume this body is extended body that way. This is the body. And it is rotating about O. Any line on AB, any line on body AB now making rotating and angle is known as displacement or angular orientation. So each point on this line which is passing to center of rotation making arc, this is circle. And this is my reference point. So x, y, z coordinate is 0. So I can find point on rigid body just by knowing theta. That's why it is pure rotation. If the whole body is moving, now this body moving, why the AB will not change its orientation. It is moving, it will not change its orientation. So this is parallel to this one and this one. Right? All AB parallel. So it may move like that way, or it may move straight line, or it will move in that direction. Such motion is known as translation. Means the movement of each point is parallel. See here, this is the locus path of point A. This is the path of B, and these paths are parallel. Means orientation of the line drawn on rigid body will not change. Then it is known as pure translation. So a line drawn on body change its linear positions but does not change its angular orientation of a line drawn on the body. So the all points on body describe parallel or parallel curvilinear or rectangular path. So here in pure rotation, uh, path of points of the body are arc, circles, and here either straight line or curvilinear, but all paths of all points are parallel. So that is known as pure rotation. When we combine both, then it is known as complex motion. So that way, AP now change its orientation. Paths are not parallel to each other. Path of B and path of A are not parallel. That type of motion is known as complex motion. So while analyzing mechanism, we have to define whether it is pure rotation, pure translation, or combination of that, and that way we are going to formulate analytical solution for finding velocity, acceleration, and position of any point on any link. So simultaneous combinations of rotation and translations is the complex motion. So the translation and rotation can happen both independently, right? You can translate without rotation or rotate without translation. That's why these are the two independent motions, right? So one exists without other. We consider as slider crank mechanism. In this slider crank mechanism, there are four links. Link one is fixed one, means fixed to the frame. Link 2 is crank. So link 2 is having purely rotation motion. You can define any point on crank by just knowing angular displacement. Is it correct? So by knowing the position here, this point, this is your reference point on any link. I defined the methodology how to find position. Position can be defined by a point on link and a line on the link. Right? So two things are needed. One is point and second one is a line. So here point is my fixed point that is also lies on the crank, and line is line drawn between joints. This is the part of my crank. Right? So this is the line on crank. Obviously, this line is defined as crank or crank length. How are you, sir? Namaskar. आप अपने पीएचडी को वहां जाओ, पीएचडी स्कॉलर उस लड़के को ढूंढो। तो क्या अभी इस समय रजिस्टर वो नया लड़का अभी दिया है? अच्छा हाँ, उसको अपडेट नहीं किया होगा मुझे सारे सुपरवाइजर। एनीवे कब तक ये अप्रूव करना है? अभी मैं 11 बजे क्लास 12 बजे फिनिश करके अपडेट कर दूंगा। So link crank is now position of crank is defined by orientation of this line and position of this point. So make a note. The position of any link is defined by two things. One, any point on the link and any line on the link. So this point will give you translation and this line will give you rotation. And by these two informations, we can find the position of any point on the link. Right? So that way, the position of any point on the crank is defined by knowing the position of this point and the orientation of this line. Right? Orientation is given by a motion pure rotation. This link is under pure rotation because translation is not here. Each point is defined concentric circles, correct? So it is in pure rotation. And point which we define as a reference point on the link, that is pivot point. So that way we find the position of crank. See here, now this is my connecting rod. Before come to connecting rod, consider my slider piston. This piston is moving in a slot, so it has only translation, fine, to and fro in a predefined direction. So there is no rotation of this link, only translation. So each point on this piston, this way moving parallel, path of point parallel. Here it is of course straight line. So path of all points is parallel. That's why it is pure translation. So these two links, one is in pure rotation, second this piston is in pure translation. Now come to our connecting rod. Suppose I want to find the position of this point and I use this point to drive another mechanism. Right? So I require this position of this point. And how do I find the position of this point? Or how do I find the velocity or acceleration of this point? Because this point is my interest and this point is used to drive another mechanism. So here this connecting rod, that is third link, this link has a complex motion. So I define two information required. One is the reference point, second one is a line. So I consider this is a line on the link which we join to join. Right? So okay, now a line is there. Reference point, suppose position of this point is known by virtue of knowing the position of the crank. So why not I use this point as a reference point? What Mohit said that use a center of gravity or center of mass, that is not necessary. I do not know here where is center of mass or where center of gravity of this connecting rod. I know this point because I know the position of crank. So knowing that this position means that this point is known. So I consider this point as a reference point on connecting rod. So the point and now this line. There are two informations are available. By knowing these two information, I can find the position of this point. How? The position of this line in reference axis, you know the angle, and knowing the angle of this line, and this angle is always remain fixed. It will not change because this link is rigid. So the motion of this link line is theta. This is now alpha. So by knowing the theta and alpha and knowing the position of this one, and this is the length which is again fixed, that will not change. So knowing the length L, knowing the angle theta, knowing the alpha, and knowing the position of this point, I can find the position of any point P. So that way I required x, y, and theta. These are the three variables x, y, z of a point, suppose A, which is known. So this vary, then x, y also vary. this move, then theta is also moved. So there are three variables x, y, and theta. Once you know the x, y, theta, then you can find the position of P. Alpha and L are the constant. They will not change. So crank rotates about O, so it is in pure rotation. Piston translate in x direction. The direction x direction is merely by defined the user. This is my if my I orient reference frame along piston direction, then it is my calculation becomes easy. That's why reference frame is orient along the piston. Hmm. So x direction is the piston direction, so it is in pure rotation, and cranking rod is complex motion. So this simple crank mechanism, how we analyze for the positions. Okay, you got it? So three information x, y, z. Similarly, for the special mechanism, use third variable z, and here alpha, beta, and gamma. These are three rotation about three directions. So in all, there are six variables. So to find the position of any link moving in space, we need six variables x, y, z, and three rotation of the line in space, orientation in space, about x-axis orientation, about y-axis orientation, about z-axis. So there are six. So that's why any body, any link moving in planar motion has 3 degrees of freedom. Any link moving in space has 6 degrees of freedom. Without any connection. Free moving. So some internet stuff I found very useful, and these are websites. I hope you will see these websites. So the mechanisms are assemblage of rigid bodies connected by joints. That is very simple definition in one line. Mechanisms are assemblage of rigid bodies. Rigid bodies are nothing but known as links. Right? And these links are connected by joints. So here two things in this one line definition, links and joints. So in second PPT we define what are the links, what are the joints, and how we define different type of links, different type of joints. Right? And these joints are not a riveted joint or a bolt joint or this joint. These are the kinematic joints. Means they allow motion. Right? So these joints are the kinematic joints. They transfer motion and mechanical work from one or more actuator to one or more output. This is the purpose. So mechanism may transfer motion or some work along with motion. Actuator means driver, motor, or force driver. So how we define number of actuators and how we define number of output. This is again one more question. Correct? So in this two lines, we have to define links, we have to define joints, type of links, type of joints, and again how many actuators are required for particular machine or mechanism, how many outputs we can obtain from that particular machine. These are defined by constraint analysis of mechanism. In normal language, we can call it DOF, degrees of freedom. Right? So Mohit, again, I target you. How can we define degree of freedom? Mohit, have you called yesterday me?
Yes, sir. I called.
Okay, fine.
Degree of freedom is the
Yeah.
number of independent variables by which we can define the position of the position of the system, or
You mix up so many things. System, position of system. What does it mean by position of system?
system, yeah, link.
Again, you come to link.
Yeah,
Number of independent, what you call number of
independent variables.
an independent variable required for find the position
Yes, sir. To define the position
of a machine. 4, correct?
yes, sir.
So position of the machine means position of links,
Yes, sir.
and position of links. Just I said that position of link is defined by two motions. One is the translation, second one is rotation.
Rotation motion.
Correct? So each link, position of each link is defined by rotation and translation. Rotation is by a line drawn it and position by any reference point on it. Correct? So these two informations are needed to find position of link. Right? Now, independent parameters means these parameters, one parameter is not determined by another parameter, right? Or we are not expressing one parameter in form of other parameter. Then it is known as independent parameter. This independent parameter required for find the motion. So for the planar link, suppose a crank slider crank mechanism, and connecting rod is there, and this is a planar motion. Planar motion means no motion in z direction. Of course, link is rigid and it is three-dimensional. But each point on the connecting rod, the variation in the z coordinate is not possible. That's why it is known as planar link mechanism. How many parameters required to find the position of connecting rod? Mohit.
Sir,
Suppose you want to find the position of a connecting rod. How many parameters required?
it's
How many variables you need?
just so it's a 2D motion, so there will be, and sir, it will be defined by the connecting joints also, where it is connected, by which we will find the number of independent variables, how much variables it required.
You do not accept the question. The question is very simple. How many independent parameters are needed to define position of connecting rod? I am not concerned about the other bits.
सर फर्स्ट तो द पोजीशन ऑफ द कनेक्टिंग, सर हमने एक रेफरेंस पॉइंट लिया है, जिसका जो रेफरेंस पॉइंट जो है उसकी हम जो रेफरेंस सिस्टम है उससे पोजीशन डिटरमाइन करेंगे, एंड एक जो एंगल होगा जिससे रेफरेंस पॉइंट के अबाउट वो रोटेट कर रहा है.
3, just we told 3.
यस सर 3.
3. So we need a 3 independent parameter to define position of connecting rod. Same way, 3 points for the connect and 3 for the piston. Right? If they are not connected, these 3 bodies are moving independent. Is it correct?
Yes, sir.
So there are 9 parameters. 9. If there is no connection, but what we do, we connect them by a revolved joint. So by joining the revolved joint, they supply some degree of freedom. So degree, after introducing joint between links, degree of freedom or number of independent parameters will increase or decrease?
Sir, decrease.
Decrease, because they will make a connectivity, some constraints. That's why the analysis of constraints means degree of freedom. So next class we defined how to analyze the constraint in a mechanism. Particularly at this moment, any link moving independently in a space needs either three or six independent variables to define its position. Right? After introducing the joint between link, how the degree of freedom will reduce, and what does mean by degree of freedom, and how do we find overall degree of freedom. You know the Gruber criteria, but I will not directly strike on the Gruber criteria. How Gruber criteria come into existence, I will discuss that in here tomorrow. Right? So now उनको अटेंडेंस से आपकी ऑनलाइन क्लास अभी अभी खत्म हो जाएगी। अभी
Yes, sir.
आप आ रहे हो क्लास में? ओके फाइन।
Yes, sir.
So this is January yes हाँ अटेंडेंस ऋषिकेश सतीश श्रीनाथ
Present, sir.
दावी दिनेश कुमार बाबूलाल
Present, sir.
सत्येंद्र सिंह सत्येंद्र सिंह नॉट अवेलेबल मोहम्मद सैयद
Present, sir.
आदित्य सिंह पटेल विजय सैनी
Present, sir.
किशन कांत शर्मा
Present, sir.
सौरभ कुमार
Yes, sir.
मोहित सिंह बेनीवाल